So what matters in brain development and why and how? And the reason why I want to go into a little bit of details in this is because I found that when I used to give recommendations to the teachers and to the support staff, they all have the good intentions of doing it regularly, but I found that the compliance rate in following through with the recommendations was a lot more when I explained how it impacted the brain. And it was amazing. I just always am amazed when people know exactly how you are impacting the brain and how much you can help the child, because I think anyone working with a child really wants what's best for the child. So explaining to them how it makes such a big difference to their brain development, they get very compliant. And being compliant with the recommendations is really one of the most important things, because then we leverage what we call the neuroplasticity principles in changing the structure of the brain and the function of the brain. So, we can do a lot for the brain if we know how to leverage the neuroplasticity principles. So why there are two things that makes a very big impact on brain development is the early caregiving environments. And why does it matter so much? Today, I'm going to try and explain that to you. And how can movement experiences also impact brain development? I'm going to go a little bit into some critical time periods. And this is just an overview. In half an hour, I won't be able to do too much. So I'm going to try. I don't want to cramp in too much information, but I want to give you some important information. So I'm going to say, how long does it take for self-regulation to develop? That's something that, sometimes parents keep asking me. And I'm like, it takes a very, very, very long time in humans. It takes almost 23 years. So the first thing that develops is something that's called co-regulation. And co-regulation depends entirely on the self-regulation ability of the caregivers in the child's life. So it's very important that the caregivers or the adult who is with the child, it doesn't have to be only, a parent, it could be grandparents, it could be siblings, it could be anyone who is with the child most of the time. Their ability to self-regulate makes a very big difference on the child's ability to self-regulate, because we first co-regulate and then we self-regulate. So again, it's very dependent on early experiences and the emotional brain, and I'm going to go a little bit on that again. The emotional brain is shaped by our early experiences. So when we are born with a very basic primitive brain, and that's called the reptilian brain. And the main function of that brain is survival. So it's all the automatic functions like breathing, digestion, circulation, all those things are the function of the primitive brain. And if there's any threat to our survival, it's going to be working, and it's very, very, very strong. And then as the child starts growing, the baby starts growing, the emotional brain starts developing. And the experiences, the positive and negative emotions that the child experiences is going to make a big difference on how they can recruit it. Because as with every thought and emotion, it's having an impact on the brain structure. So if they're feeling more of negative emotions, that is what is going to be reinforced. And if they're feeling more of positive, so if they're feeling loved and supported, and they're having good, nice, healthy interactions with the adults, then that is how their emotional brain is going to be shaped. And this is happening, till around 13 years. And then you have the neocortex, and you can see the neocortex is more the thinking part of it. It's the executive skills, your ability to problem solve, to be creative, your academic skills and everything. I mean, it's not that you don't have your academic skills before that, but our ability to fully use it is completed around 23 years. The neocortex is the one that is more like a regulator. It controls our emotional brain and our amygdala. I'm going to go into that a little bit, when we are having negative thoughts and things like that. But that doesn't develop until around 13 years. And it needs the connection, going from the emotional brain to the neocortex and then coming back. And that takes about 23 years. So it's very, very important that we deal with children on an emotional level and not ask them to think about things. You first make them feel better because they are from their heart level, they are from their emotional brain. So this is a very important thing. I'm going to go really quickly. The amygdala is in the limbic, in the emotional brain, and it is connected with, your fear reflex. So it's very, very strong in children, and it's very reactive because the nervous system, the main function of the nervous system is survival. So if for any reason a child picks up any cues that they are not safe, it's going to be active. And in an adult brain, the neocortex is going to have the controlling effect on it. But in children, especially up to 13, it is the effect of the caregivers and how the caregivers are reacting with them. So that's really very important. Um, the reactivity of the amygdala is more when the child is younger, and it becomes less and less as the child grows. And of course, it's controlled a lot when the neocortex is completely developed. Um, like I said, caregivers make a very big difference to the child. So it's really nice if the child has, of course, if all the caregivers are good, is very good. But the research says that even if there's one person who believes in the child completely and who doesn't give up on the child, it does make a difference. And of course, the most ideal would be if it is a parent at home and the teacher in school. So I just wanted to say, when the adult is, there are ways in which we reprimand and the way we shape. But if you start, trying to teach them lessons when they are upset, they're not going to learn. I just want to share a funny story. Now my children are grown up, but I remember I used to, when I used to try and talk to my son, and all of us have made mistakes, in our parenting, we're all learning. But I remember when I used to sit him down and I would talk to him and I would think, yeah, I'm doing a great job. And I remember he would be on the stairs and I would be talking to him. And I could slowly then start just seeing him smiling. And it would get me so mad. But afterwards, when he was, when they were older and we would talk about all our childhood experiences, I used to tell him, that's the one thing that you used to do that used to get me so mad. And he said, Mom, I used to just, he said, you used to talk so much. Like I would just see your mouth moving and it would make all these funny shapes. And that's what I was watching and smiling. And I was like, my God, I learned something from my son. Do not talk to them too much when you are disciplining them. Just be right to the point. So I'm sure all of you all can, not all, but most of you can identify with that. So again, what is really co-regulation? Co-regulation is so important that I said self-regulation is not developed right from the beginning. It is co-regulation, and it occurs between a child and a warm, responsive caregiver, where the caregiver meets the child's physical and emotional needs and soothes and calms the child when they're experiencing those big emotions. This in turn builds the neural architecture which is necessary for the child to self-regulate. This is so important because we're shaping the emotional brain for the child. So, we are mammals. And so even you can see there are mammals that also co-regulate, and we are humans. And it's very important that our early caregiving experiences are shaping on and nurturing our brain the way it should be. So now I'm going to move on and just give you a little bit of an idea of how the nervous system is the system that regulates our behavior and our emotions. And it consists of the central nervous system and the peripheral. I just went over the central nervous system with you with the brain. The peripheral nervous system has the autonomic nervous system and the somatic. And we are concerned more with the autonomic. It's very easy to remember what the autonomic nervous system does because it's all the automatic functions. It's the functions of the heart, of the liver, of the lungs, all those things that we do not have control over. So it's all the automatic functions. And it has two important branches, the sympathetic and the parasympathetic. So a very easy way of remembering is, whenever we get stressed, we we get engaged in our stress response, and that is the sympathetic. So the sympathetic actually has, it gets our body ready to fight or to escape. And the innovation of the parasympathetic and the sympathetic is almost to the same organs, you know. So you have the sympathetic that gets us all ready to fight, as it, you know, causes dilation in our eyes, our heart rate goes up, we start breathing fast, and, you know, all these different organs. And the same thing happens, the same organs are innervated by the parasympathetic. So once the fight and flight is taken care of and the stress is gone down, parasympathetic takes over. So it's like rest and digest. You can consider it like the brake pedal and the sympathetic as the gas pedal. So it just brings, cools everything down, calms everything down, and then we can do things like eating and studying and things like that. So the person who first, you know, made us aware of it was, he's a physiologist, he's Walter Cannon, and he told us there are two responses. One is the fight and the other is the flight. So we have seen this. I'm going to refer, this is seen in everybody, but I'm going to talk mainly about children. So you will see it, you know, you'll see it in their eyes. It's more like a hyper arousal. They're always looking to see, like, for escape. So that's one of the things you see. Then you may see like a little bit of trembling. You can see that you won't be able to see their heart rate going up, but you will know that their breathing has changed and they get a little bit flushed. So you can see it, or you can see the reaction on the person. There will be a change in them. And I can easily make out, I don't know whether I'm a physical therapist, I think most mothers will pick it up too. You can see that they're ready, you know, their whole body gets toned and things like that. So to run. So in children, we clearly see it as when they feel a little bit of threat, they want to first run. And if for any reason they can't run, then they're going to fight. And if that doesn't work too, I see it later on as they grow up, they freeze, which basically means that they isolate themselves, or I'm going to go into that a little bit more. Now we have a lot more, a much better understanding about our stress response. And Dr. Stephen Porges, he's a neuroscientist. And in 1994, he gave to us the polyvagal theory and gives an explanation, a much deeper explanation of our stress response. And I think it's really important for all of us to know more about it. He talks about, you know, our behaviors and everything, it is dependent on neurophysiological state. That is the platform from how we respond. So I'm going to go a little bit into it and explain that. He found out that it's not just two responses. It is the flight, fight, and the freeze response. And why does that make such a big difference? It was pretty revolutionary because the freeze response is what we see in children who withdraw, you know, who are suicidal, you know, the ones who have a lot of trauma. So they're not fighting or they're not running away. So it was an addition which I knew even before his information, what Dr. Stephen Porges had shared. But what is really revolutionary about what he shared with us from his research work is the neural systems that are recruited during freeze. It's not the sympathetic, it's the parasympathetic, but it's a completely different parasympathetic, meaning it's a primitive parasympathetic. So it's not the sympathetic nervous system, which is in human beings, with the neocortex. This is connected more with the primitive brain that the child is born with. And that's not myelinated. The other parasympathetic is myelinated. So he explained it and he said it is because the nervous system has a function called neuroception, and it is the subconscious ability for us to detect threats, risks, and safety. And it's a very, very primal function of the nervous system. So neuroception is what will set the tone for that platform that I was talking about. And there are 3 different neural networks. By the time we we basically shape, I'm making it really very simple, rather he made it very simple. And he said, look at it as we have a choice of recruiting three nervous systems. I'm sorry, pathways. So think of the traffic lights, it would be the red, the green, and the yellow. So when we are in a defensive mode, we will be recruiting the red and the yellow. And when we are in a socially engaged, when we are feeling safe, we will be recruiting the green. So again, whatever our emotional experiences were, they shape our go-to strategies by the time we become adults. So if we used more of the red, then it's going to show in the way we respond when we're adults. If we used more of the green or the yellow, then those are the neural circuits we're going to be using. So when do we use the yellow? We use the yellow when we have past memories about something, and if it wasn't pleasant, it could be with the person, it could be with the place, anything is going to get us to be in our defensive mode. And it's also associated with how, the child is feeling judged, if they're blamed, if they're humiliated, if they're shamed, or if they're made to feel guilty. All these things will automatically, I want everyone to understand that it automatically puts their nervous system in a defensive mode. You can't control that. Your emotions, you cannot control it. And this is very reflexive. So they are going to be in this mode where it is defensive. And when you're on the defensive mode, you're not in the zone to pay attention or to learn or do any of that, because you're just, you feel your survival is threatened. But if it is a much deeper level, then you are going to use your red neural track, which tells you that you're in danger. Your survival is really threatened. And you either freeze or you get suicidal or you shut down, so it's all those type of features you're going to see in your child. And when you recruit the one that, where we could actually use our neocortex and our thinking skills, would be the green one, and you problem solve, you get very creative, you socialize better, and you play and respond like the way we would, want people to respond instead of reacting. So once again, when you engage with the green track, it is you're feeling safe and you can engage. When you feel there's danger, you're going to go use either your fight or your flight. And when you think your life is actually being threatened, you go into the shutdown mode and you use the red track. So again, I know there are many professionals over here too, so I'm going to go really quickly. I made this slide to, give you a review of everything that I said. I know it's a little bit heavy, but I'm going to try. The nervous system, the autonomic nervous system, is structured in a hierarchical structure. And we have three systems. The first system is the social engagement system, which is for breath, heartbeat, facial expression, and voice. The second one is the sympathetic, where it mobilizes us. And the third is the primitive, parasympathetic. So the social engagement system is the myelinated system, and it really is very quick. So we are always using that first. And we use that based on our feelings of safety, whether we are safe or we're not safe. So I'm going to first talk about when we feel safe. When we are safe and we want to do something, then our heart rate goes up and we can engage in work, art, play, things like that. And a little bit more, and we can go into sleep, because that's what happens. Remember, when you're feeling safe, the parasympathetic is with decreasing your heart rate, your breathing comes to normal. So when you go into deeper, when your heart rate goes down even more, that's when sleep. And the beautiful thing that we know now is we're using that for meditation too. So what happens when we are not feeling safe? We first engage, it will first go to the green system, which is the social engagement system. But if the message comes down, this is all reflexively, when the message comes down that no, we are feeling threatened, then the child is going to try and run away first. And if that doesn't work, they're going to try and fight. And if that doesn't work, they are going to go into their shutdown mode and freeze or faint. When you are older, that's what you do. I mean, maybe children do. I have personally not seen that. I've heard about that only in adults, the fainting and dissociation. But they could get seizures, that could happen too. So now, as a child, I said, growing up after 13, you may sort of connect with the social engagement system, but if you still feel threatened, you may not fight or flight, but you could resort to, manipulation, sarcasm, passive aggressive type of behaviors that we see more in adults. And you could see it in children too. So the nice thing is you can keep shifting between all these different stages, and that's what we want to leverage on. So if someone is engaging more in the negative, then we can get them to engage in the positive. And that's the beauty of our nervous system. I feel we're engineered so beautifully that we do have the choice. We have the choice, and we have the choice primarily because there's only one physiological function that is not under our control and under our control. And I'd love for you guys to guess what that is. What do you think that is? And I'm sure all of you guessed right. It is our breathing. So breathing is something that it's our window of opportunity to get in there and change the state. This is the reason why just thinking about it is not going to make a difference, because thinking doesn't change the visceral responses. It's our breathing. And that will have an impact on our emotions because we are getting in through the parasympathetic through our breathing. So it's really important that we teach breathing skills to our children, effective, intentional breathing. I wanted to say this, I wanted to throw it in there and say that with strategy, when we are dealing with anyone, and of course with children, I'm going to talk a lot more, with strategy is the worst. Shame is definitely the worst. And you don't want to raise a child with shame because that becomes their self-talk. They start thinking they're stupid, they're not lovable, they're ugly, they're not worthy, and they're not extraordinary. That's what I find with neurotypical children is they feel that they are not extraordinary enough for the caregivers in their life. And we should just reflect when we are expecting to